Okay, so I'm recording this for all of you to use later for the task 4, the skills task. So we went over the social network analysis on Tuesday, and then today we're going to cover text analysis. There's a lot to cover, text analysis, because of the pre-processing steps. There's a lot to cover in this task, but they're basically two files that you need, two Python files here. So I've divided the Python code up into task 4.1 for processing, is pre-processing, and then task 4.2 is the keyword analysis. So I could have just done one long script and included everything in there. The reason why I broke it up here with processing tokens is because when you take the text and then you process it and clean it and delete all the stop words and lemmatize and all this stuff, and when you finally get these clean tokens ready to analyze, now you can analyze that in a lot of different ways. So you can do a keyword analysis with that, or you can take those tokens and do like a latent topic analysis. So this is like processing the tokens is a good place to stop, right? And then save those tokens, like export them out as a file. And then task 4.2 will open up those tokens again and then continue with a keyword analysis. So if you wanted to do latent topic analysis, you would run 4.1, export the tokens, and then you would write a different script for the latent topic analysis. And so so there are two supporting files for 4.1. One is the corpus index. It's an Excel file, and the second is a extra stop words text file. Let me just, I'll show you those in a second. Lastly, there are two folders. So in addition to the code at the bottom, the code in the main folder, right? These 4 files in the main folder, there are 2 additional folders. So there's a corpus folder, which has a bunch of text files, right? These are the text documents. And then there's a second folder called results. And this has an R file in it. So task 4.1, when you open this up, it's going to use the corpus index. The corpus index has a list of all these files, and it's gonna open up the corpus index, and it's gonna also open up this corpus folder and one by one pull the text out of each of these text files, and then it'll process those text files into a corpus tokens. Once you're move on to task 4.2, you're going to take those tokens and do some keyword analysis with them. Then you're going to be exporting things to the results file, right? So the folder. For example, like if you're going to do the top 25 words, or you're going to do a bar graph or a line graph or something, I export all those the graphs from task 4.2 into the results file. And just like with when we had task 1 and 2, you constructed the data set in task 1 using pandas, and then you exported Excel the data as Excel spreadsheet, and then you would open it up in R to actually make the graphs. That's what we're doing here. So task 4.2 is going to export some Excel files into the results folder, and then task 4.2, the R file here will open up those text files and let you make some graphs. So this R code is really short. This is opening up, I think, like 3 Excel files and then like making 3 graphs. It's going to look exactly like very similar to the task 2 R file. So I'm just going to. So when you're doing this task, you need to download this code, these files in the following way. So let me show you. Well, so let's say here's my project file, task 4, text analysis in Python, and then I've downloaded right? Those are the 4 files from Moodle into my main project folder. And then I also have 2 folders here, right? The corpus folder and the results folder. So in the corpus folder, that's where you're going to save all these, right, text files. And then in the results folder for now, you're just going to put the R code. And then these other things that are in the R in the results folder are output from the first step. So I think I have. So let me show you the corpus before we start processing. So here's I'm going to open up corpus index just to show you what the corpus looks like. I will have stuff open. So this corpus is actually not that big. It's just 34 documents. So the way I constructed the corpus was I went to Astana Times. Are we gonna have slow internet today? So I searched for prisons, and I just sorted by date. So if you do this, I just wanted to do text analysis on prisons. I just want to know about prisons in Kazakhstan. So you can see like each of these news stories. This is July 20th, 2022, July 15th, 2022. And there are 10 articles per page, and there are 4 pages. So there are less than 40 articles, right? The 4th page has like 4 articles. So there are 34 articles in the English language Astana Times dating from 2013 to 2022. Right? And then to construct the corpus, basically I opened up each page. And just right, here's one article: public officials visit remand prisons to cultivate zero tolerance policy to corruption. So I just copied and pasted this text into a text file like this, and I also included the. Normally, if I was doing this with a very large corpus, I would use I would scrape it, right? If I was going to scrape like 1,000 or 10,000 articles, but for this, I wanted to do it by hand so that you could also use this method by hand if you're going to do something that's between 50 to 100. You know, I mean, 100 articles might take a long time, but it's not impossible, right? You get a research assistant to help you out, and you can do it in a couple of days, right? So so this is each of the text files is just the title and the text, right? And then and then I save the text file by its date. So this was July 20th, 2022. So in the corpus, you can find it here, right? It's this file right here, 2022 20220720. So I often save my files like this, right? Why do I save by year and then month and then by day? So if you save them by 4 digits per year, 2 digits per month, and 2 digits per day, then they're sortable, right? And when you sort them the sorting corresponds to the date, right? So the numbers, like this 8-digit number, if you sort it, right, the smallest one is going to be the earliest doc file, and the biggest one is going to be the latest, right? So I always like, as much as possible, like try to use smart coding when you use the file name, right? So that you can just like sort the document names. It's going to be the same as, you know, the data is going to be sorted in order that I want. And the other thing is, like, if I want to grab, say I wanted to, later I'm going to do a time series, right? Like I want to know the keyword counts for 2013, 2014, 2015. Now all I have to do is grab the first 4 digits from the file name to know is the year 2013, right? I don't have to go back and refer somewhere else to figure out like what's the, right? So as much as possible, if you can encode useful information in the file name, right, then you can save yourself a lot of time. So that's how. Yeah. I guess KIMEP. I noticed online here. I just noticed one of my 206. This one is not 8 digits. 2061115. So that should be. Where is that one? Oh, maybe I didn't. Okay. So by the way, like I did have my RA help me with this, and he put them in Word files, and then I didn't. Wait, I said, where's my 2016? There it is. Yeah. Extra one in there. Okay, so I'll change that. So you can see here, even though there are 34 articles here, I was only able to transfer 21 of those over to text files. So today the analysis that I'm going to show you is of these 21 files, but I'll upload the rest of them later. So when you actually run this, there'll be 34 text files. So it might throw off the time series a little bit, but anyways. Okay, so this is the corpus. That's how the corpus is structured. So I put I create an Excel file where I put the file name, which is also the date, right? And then the description, which is, I just include the title. Now, this is where, you know, this Excel file is where you would add any additional metadata about the article, not the text itself, but any additional metadata. For example, if your corpus is grabbing some articles from like a liberal publication and some from a conservative publication, and you want to be able to code those, right? Or, you know, English language and Russian language, or whatever kind of metadata you wanted to save about those articles, you could add that in here. And then you've always got the metadata available in one centralized place. Whereas the text for the files, I like to keep separately in these kind of simple text files. So, and I already showed you these. You can just open it up, and it's just text, no pictures, no formatting, no HTML, right? So this is why if you're doing text analysis, text files are great, because if you copy and paste stuff into Word, you're going to get all kinds of weird like HTML and like code behind the words, and when you read that, it's going to actually give you the words in the document plus all the HTML that you don't need, that you don't want. So the easiest way to avoid that is just copy and paste into a text file. Okay, so that's the corpus, that folder, and then this index, and then, okay, so let's open up, let's go to Jupyter Notebooks, and I'm going to open up this 4.1 tokens, process tokens. So here's my Jupyter Notebook. So we're not going to be doing latent topic analysis. What we're doing is preliminary steps. I showed you how I constructed the corpus. We're going to import the corpus into Python. Then we'll process the tokens with this script. And then we're going to export those tokens as a file and close this script and be done with it, right? And then we'll open up the second script to do to do the keyword analysis. So the second script will then open up those tokens, take those tokens, open it up, and then do the keyword analysis. So 2 separate scripts. So I already talked to you about how to construct the corpus, and now we need to import it. So I'm going to be using pandas off and on. I'm going to use OS. The OS library here, if you don't have it, you need to install the package. OS means operating system. OS in Python is the library that allows Python to interact with your computer. No. So you need to do like install packages OS like that. Install package. Is it? I think I have. You can do like pip install. This is R. I'm sorry. I'm like my head is in R right now. Pip install like OS. You could do that, and then right, you could run it, and it's just going to tell me like I already have it. Right. So, anyways, so that one you'll need, and then of course like Panda, you'll need pandas as well. But these ones you only run once, and then you run those once, and once you have it, then you just comment them out because and then you can import it as you need it. So I'm going to import pandas and import OS. I have the path here to my corpus, right? All I'm doing is creating a relative path from my main folder to the folder where my text files are saved, right? So that's corpus. And then this is the file name for my corpus index. And then I'm going to import the corpus index. I'll just read that in as an Excel file. And there it is. So that's this corpus index file, right? I'll just close that in Excel. Okay, so I've got the corpus index. Actually, I don't really need it right now because I'm going to use this OS library to to list all of the files in the directory of the corpus path, which is, basically this just says like, hey, go into this folder and tell me what are all the file names in there, right? So I just grab all the file names in corpus and run that. And so that's all, however many, 21 items, right? So I've got some like 2013 down to 2018, and then I've got these ones from 2022, but I have a gap here between 2018 and 2022. A few files off to add. Okay, I'm going to run through. There's a lot of code here. I'm just going to tell you generally each step what I'm doing. I'm not going to explain like line by line, right? So here, basically, we're opening up. I've got a for loop on this list of file names. I'm going to open up each file, grab the text, and save it in a list. Right? So, and I'm going to call that doc text. And then the doc IDs, the document IDs are just going to be these dates, right? So these are unique IDs for each text document, and the text I'm going to save into this list. So right now I did that. I've got 21 documents, in Python now. If I can see the list of doc IDs, right? And doc 0, this is the doc text 0. This is just one example, right? This is the first item in the list. This is the complete text of the first of this document 2013-0504. So I've got the text now, and notice it's saved. What's the data structure here? Data structure for each item in doc text is a single string. So I took the entire text of each article, and I'm just saving that as one single string. Okay. And then, so doc text just has 21 of these. So if you want to look at a particular article, right, you can find like doc 5. Let's see. Right. There's calls for broader cooperation, right? If you want to see doc 10, you can put that in there. public safety, right? So, okay, so now I'm going to process the tokens. These are all of the pre-processing steps I'm going to do. First, I'm going to take the string and I'm going to chop it up into tokens. And then I'm going to make everything lowercase. So I'm going to totally ignore uppercase, okay? But then I'm going to lemmatize. Lemmatizing is things like, you know, asks, will, right? Like any kind of variations on which are, yeah, declined, I guess, and declined or conjugated, right? It will take like the infinitive or the base form, right? So that will reduce the number of tokens. It will take any kind of family of words that have the same root word and just compress them all to that same thing. Right? And then lastly, I will remove stop words, which includes things like the, a, and, right, and also like punctuation and other things. So things I'm not going to do, which normally I would do in a more, if I was going to be more thorough, are parts of speech tagging. So you'll see here, for example, when I tokenize, like you'll see an abbreviation, for example, for like United States, you'll see like US. And then when it gets short, lowercase and then lemmatized, it turns the US into like a U, and then it gets cut out with stop words. So, right, but if I did parts of speech tagging and I identified US or USA as an acronym, right, then I would pull those acronyms out and I wouldn't lemmatize the acronyms, right? Or I wouldn't run maybe I wouldn't run lowercase on the acronyms because those are treated separately, right? So, and also some parts of speech, for example, like articles and prepositions, some certain parts of speech you can just like throw away from the very beginning because you're going to throw those out with stop words anyways, right? So you can do much more sophisticated pre-processing if you tag every token with a part of speech and kind of treat it in a more sophisticated way. I'm not going to do that. I'm just going to kind of bulldoze through. And you know, you'll still see the tokens are still like quality tokens, but you know, these methods are going to do a little bit of damage. They're going to do a little bit of damage to the tokens that parts of speech handling might have not done, right? Been a little gentler. And there's some other pre-processing steps like chunking. There's a lot of stuff in here. This is all like natural language processing stuff, which linguists are much better qualified to speak to. So a lot of times, like myself and when other sociologists kind of apply these methods, we just kind of like bulldoze over the text and hope we do minimal. Hope the damage we do isn't too bad. So you can find out most of these steps are done using the MLTK library, and you can find the API there and there's some tutorial that kind of gives more detail about that library. So okay, and so to do this, you're going to need to install NLTK. NLTK can be a little bit hard to install. Sometimes this pip install NLTK doesn't work for like Mac or some PCs. And then in that case, like follow these instructions. Right? So if NLTK doesn't work, kind of look up here, and I have some things that you can try that like run NLTK, install NLTK, run the command prompt to the PC or terminal. Like it may not work here in Pandas, or sorry, in Jupyter Notebook. So anyway, if you have trouble installing NLTK, let me know and I'll make sure you can get that installed and working. Everything else is fine usually. So I import NLTK, and then I'm just going to go through these steps like pretty quickly. I'm going to tokenize, lowercase, lemmatize, remove stop words. So okay, importing NLTK. So we're going to tokenize, importing my tokenized library. Here's an example string from the great novel Dune. Muad'Dib learned rapidly because his first training is in how to learn. Okay, so here's just a sentence, right? And then if you tokenize it, this is what it does, right? It takes that sentence and it chops it up it basically chops it up on the white space, on the spaces between words, right? So these are all tokens. Muad'Dib learned rapidly because his first, etc. Right. So now I'm going to do that to here's my document. I'm going to do that to each of these. So I did that for each of the 21 documents in doc text. So now each doc tokens now is a list where each item in the list is another list of tokens that correspond to each text document. So here, again, I still have 21 documents. The first document has 786 tokens, right? Which means it chopped the first document into 786 words, right? And then if you want to see the first 20 words of that first document, right? So you can see here's the text, right? Harmony lesson, is it? Right, so this said Harmony Lessons honored at Tribeca Film Festival. And then down here, you can see it took the quote separately as a separate token, right? The quote, Harmony Lessons, quote, honored at Tribeca Film Festival, quote, Harmony Lessons, blah, blah, blah. I mean, that's the title. And then, so you can see a lot of stuff in here that we don't want, right? Those quotes we want to get rid of, like at and it, probably we want to get rid of. But anyways, these are the tokens. And now we're going to turn these all lowercase. So I just converted all the tokens to lowercase. Now we're going to lemmatize them. So by the way, NLTK is for the English language, right? Maybe in Spanish, I'm not sure. But anyways, the natural language processing, this is where you have to use language-specific tools, right? So I only know like NLTK, colon P, which is like natural language processing for Korean, and I know a Chinese one. So I've never done language processing on Russian or Kazakh. So if you want to do, but some of these things like tokenizing, you can usually use a generic one for, and like lowercase, you can probably, no, I don't know. Maybe use NLTK, but once you move into more sophisticated things like lemmatizing, it absolutely has to be language specific, right? So, so you'll have to look around. Like I'm 100% sure that these tools are out there in Russian, like no problem. You know, cutting edge stuff in Kazakh, not so sure, right? You might want to ask Jules. He probably knows about this stuff. Here's an example, right? Here are words in cars, and if you lemmatize that, then you get here are words in cars. Sorry, here's the original one. If you lemmatize it, here are word in car. Right, so it's removing the plurals, right? So I'm going to run this on every token in every document. And okay, so here's the original. Here's the first 10 tokens, lowercase tokens of the first document before I lemmatized, and then I'll show you the first 10 after I've lemmatized. Did it change anything? Lessons went to lesson, right? So, I mean, it didn't do a whole lot to this, but right, basically, like anything that was plural, it made it singular. So, anyways, that's lemmatizing. We've done that. Now we're going to get rid of all the garbage, right? So we're going to remove stop words. There's a stop words library for English. These are the first 20 words in the stop words dictionary. So if it's one of these things, it's going to throw it out, right? So, but this is only a list of like 120 words or something. So you might want to add your own stop words to the list when you look at the text and see stuff in there that you don't want in there, right? So So here's an example of removing stop words from a quote, sir, I protest, I am not a married man. And then you tokenize it and remove the stop words. Right. So it took sir, comma, I protest, period, I am not a married man, exclamation point, and it removed I am not, but it still kept the punctuation, right? So, so what I do is, that's the second file. Here, this extra stop words. So I added this text file. So extra stop words, you can just pop this open. And if there are any extra, right, these are things that were showing up in something else I was doing that I want to get rid of. You can just like add stop words, add anything on here that you want to get rid of, right? And then just save it as this extra stop words. And then here, basically, I open up the extra stop words file. Where is it? I'm gonna run this. All right, so the original stop words, there were 179 stop words. And then I'm taking all the extra stop words that I added in that extra stop words file. I'm just going to add them to the list. So when I add them to the list, now I'm checking for 193 things instead of the original 100, right? So you can just add as much as you want. And then I'm going to run this on all of the tokens. And if it's a stop, if the token's a stop word, I'm kicking it out. And the other thing I'm doing here is if the token is only one character, I'm also kicking it out. So this is going to pick up any of my garbage pronunciation, punctuation, stuff like commas and quotes, and anything that's like one character long is gone. Right? So this is, again, this is kind of a rough shot, a very shotgun approach. All right. So here are the first 10 tokens after I lemmatized, but I have not removed stop words. And now after I remove the stop words, I'll show you the first 10. Right. So that's gone, right? Harmony is there, lesson is there, honored, at is gone, Tribeca, film festival, that's gone, right? And then let's take the next few. So this is, so I removed all the stop words. So, and now originally this document had 786 tokens, and now it has 389, right? So after lemmatizing, after spitting out stop words and all this stuff, right? Now I have 389 kind of higher quality. I wouldn't say super high quality, but they're higher quality than the original 786. And then here are all 389 of them for the first document. So you can see probably like, I didn't catch that, right? What else? This, Robert De Niro. Also, here you can see some of the sentences didn't have white space, so they didn't get tokenized, right? So if I would go back, if I was doing a research paper on this, right? I would go back and I would put the space, go back to this original text file and make sure that there's a period and there's like a space, and then Nero would have been separate, and then before would have been kicked out probably. So there's here city, that's a mistake, that's a mistake, that's a mistake. That's not a mistake. Must sees. I mean, that's just like so you have to decide how you want to handle like hyphenated words. But I don't worry too much. I don't worry too much about garbage. Why? Because when we're doing the keyword analysis or the latent topic analysis, it relies on frequency of tokens, right? So most of these things, right? When I look for the top five most frequent and top 25 most frequent tokens, or my latent topics are building latent topic models based on high frequency vocabulary, right? So if there's like one garbage token in there, it's not going to pop up. It's not going to be like my top 25. It's not going to influence my latent topic models, right? So I don't worry too much if these things aren't like perfectly clean. What you don't want is high frequency, low quality tokens, right? So like your quotes, they're going to be quotes in every single article, and I don't want like a left quote to be one of my top 25 keywords, right? So it's the high frequency ones that are the problem that you have to make sure you get rid of. But I don't see anything bad here. So, and again, like you're missing one thing that this kind of like super simplistic approach misses are like compound words, right? For example, New York, that's New York, right? So if I had run parts of speech, so like a sophisticated parts of speech model, probably like New York would have been pulled out as a proper noun, right? And then I wouldn't be having like New and York as two separate tokens. It'd be like one token uppercase, right? So Whoopi Goldberg, right? Like that would have pulled out Whoopi Goldberg as a proper noun, right? So there, that's you know, any of these like proper names, proper places, Tribeca Film Festival, New York. So a lot of these like proper nouns probably like be better to handle with parts of speech model. So okay. Anyhow, so you can add extra stop words. If you kind of look through this and you say like, oh, there's another stop word, then you can go back to the stop words file, you know, add it, save it, and then like run this bit of code again. You know, run this bit of code again, and you can filter it one more time. Okay, so I'm done processing these tokens. I'm ready to move on to keyword analysis, but I don't want to do it in the same script, right? So how am I going to export? I have 21 documents worth of tokens, right? It's a list of lists. It's a fairly complicated data structure. I don't want to export this complicated list of list data structure. And also, by the way, like each of those lists have different length, right? The first document might have 389 tokens. The second document might have 200 tokens. So it's not like convenient to put this data into like a spreadsheet, right? So how do you want to like, how do I preserve this data structure and close this file, right? So the easy, simple answer to this for Python is serialization. You can take any kind of object in Python, whether it's a list or list of lists or dictionary or anything, and you can pickle it. You guys know pickles? Yeah, you do. You go to the supermarket, you get a big jar of pickles. You have pickles? Yeah. Cucumber pickles. Yeah. Right?
Ones that taste
tomato pickles.
Great.
Yeah, exactly. Well, that's what we're gonna do. We're gonna pickle this. Yeah. So this is called pickling, right? You're gonna take that thing and you're gonna preserve it so you can eat it anytime you want later. That's the idea. So this is this library called pickle. You import the pickle library, and then basically whatever you want to, whatever data types or structures you have from Python that you want to save, that you want to export, you pickle it. You put it into a pickle file, and then export it. So I'm going to dump three things. I'm going to dump my doc IDs, the text, and also the tokens into a pickle, and I'm going to export it, right? So it's basically like exporting an Excel file or exporting any kind of file. But what the thing that I'm exporting is a pickle file. You cannot click on a pickle file and open it up, right? It's going to be like unreadable. The only thing you can do is you save it, and then later in Python you can unpickle it, and you can extract whatever data structures you threw in there. Now, when you open up the code again and you unpickle that file, you can pull those exact same data structures out again in whatever form they were in, right? It's like no questions asked. Oh, you wanted a list of dictionaries or whatever, some super complicated thing. When you pickle it, it saves it out as a file. And then when you open it up later, when you unpickle it in Python, it'll pull like that exact same data structure out again. So that's all it is. So and do that. And then you can see here, you can see that right here in your folder, right? So here's my tokens process. It's the .pkl file, it's a pickle file. You just let it sit there. Right? And then I'm going to close out 4.1. So, okay, so, and then in Jupyter Notebook, I'm going to open up 4.2, keyword analysis. So I processed the token, I've constructed the corpus, imported it, processed the tokens, pickled the tokens, closed that file. Now I'm opening up a new file to do the keyword analysis. So I want to show you maybe 4 things. 3 of these are visualizations. So I'm just going to show you how do you visualize the top 25 keywords. Right? This is not super pretty. I didn't spend a lot of time on the visual, like on the aesthetic side of it, right? But it's there, and then you can adapt this if you want the top 5 keywords, the top 10 keywords, right? However you want to fix it up. I'm just giving you like bare bones visualizations, and then probably more importantly, a time series of keyword frequencies across. So here, I let you choose like 2 keywords, 3 keywords, however many keywords you want to choose. And then this will make a time series from 2013 to 2022. What's the frequency? Each keyword will be a data series, right? In a line graph. So if you have 2 keywords, you'll have 2 data series. If you have 3 keywords, you'll have 3 lines. So first thing we have to do is open up our pickle. So there's the pickle. Here's the, I'm going to open up my corpus index again. Yeah. Tokens process PKL, the file name. Let me do this separate. Okay. I'd already run it once, and it's like one of those things when you like read the lines, it like pops them out, so you have to like reopen it again. Okay, so I think hopefully, fingers crossed. Nope. Where's my pickle file? Well, I'll fix that later. I'm not sure what that is. Okay, so I'm just going to move forward. I have these three in memory already, so we'll just move forward with these three documents. I'm not sure, I didn't run into that error before, so I don't want to mess with it right now. So I've got these three documents, and we'll just do the visualizations based on these, and then hopefully I can fix this one after. So here are the tokens. Let's see. All right, so let's jump into keyword analysis. So you're going to still use NLTK to do frequency distributions to calculate the frequency of each of the keywords, right? So here's a tutorial on that. So again, you're going to import NLTK, and then the frequency distribution I'm going to run on. Okay, so here the document tokens is like, now I have three documents, so it's three documents, but I had 21 or 34. It's a list of like 34 documents. I'm going to smash all those tokens together initially to do my frequency, right? So if I want to find the frequency of a keyword, I need to know what's the frequency of that keyword throughout all the documents, throughout the whole corpus, right? So that here is where I kind of take all the tokens from however many documents I have, and I add them all to one list here, token. So for these three documents, it has a total of 828 tokens, and that's what I'm going to base my frequencies on. So here, and then, so if you run the frequencies, these are the frequency, this is the token and its frequency ordered, right? So NSC, in these three documents that I'm looking at, the most frequent term is NSC. Is that like National Security Center or something? Whatever, who's responsible for prisons? It's like NSC. I mean, Kazakhstan is 12, operational 11, anti-corruption 10. This is the frequency of those tokens in the three documents. Right? And then it goes all the way down. There are 512 of them, but these are the most frequent ones. Yeah. And then, so create tuples, and then can sort. I already sorted them. Okay, so now I just want to visualize the top 25 keywords in a bar plot. So just going to grab the first 25. Right, so here's the top 25 keywords. Like not super insightful. So I take the keywords and the counts initially because I want to run like a bar plot here in matplotlib. So matplotlib, NumPy, matplotlib is Python's visualization software that lets you make like bar plots and things like that in Python. I don't like it. I prefer R. So this is where I'm going to do one in matplotlib just to show you. But then usually I take the data and I export it to an Excel file, and then I make my visualizations in R. So if I spent more time learning matplotlib, maybe I would like it. But I really I've played around with it, and I still, at the end of the day, I still prefer R. It's my preference. So here's the here's Python's version of this top 25 keywords in the prison corpus. Right here, this is the code that you use to make that plot, and you can change the title or whatever. And I just save it to the results file. So here you can output it. So I think it's this file here, top 25. So there, you can visualize like top 25 most frequent words, right, in those three documents. So NSC, Kazakhstan, blah, blah, blah. You know, also like Chop-Dash, like matplotlib, you have to play with all the spacing and everything. Okay, so instead, what I prefer is just create a data frame, right, in pandas, and then export that. I'll call that V1 for visualization 1. and just export it to results as an Excel file, right? So that's here, V1. And then you can open up the R code, right? And then you already saw this with the task 2, right? The read Excel to open up the Excel file. ggplot2 is the graphing functions, right? Here I'm opening up the Excel file, and then I have three that I'll open up, and then here down this is the top 25 keyword frequencies, and I have to turn those to make them readable, but it's the same plot, right? And you can add the title and whatever, all the stuff that was in task number 2, you can like throw in here to make it colorful and visualize it and whatever. So this is the top 25 keywords. So I thought, you know, this is a bonus. You don't have to do it, but I did put the code in here in case you like doing word clouds because it's just fun. So, so there's a website, lots of websites to do this for free. Like here's the Python word cloud, which I think is more complicated because you have to install the C++ virtual machine. It's annoying. So I just use a web-based one called wordclouds.com. It accepts, it wants the data to be in a CSV format in a very particular way. So that's what I do here for you is like format, like the hex codes, like to color it, you know, URLs, whatever. So I just, this is the format that the website wants the data in to make the word cloud. So I take your 25 words, I weight them based on the frequency, and then the word cloud website, it will make them bigger or smaller, like based on the weight, right? So you can kind of visualize like the bigger words are like the more frequent ones, and the smaller ones are less frequent. These are just colors. I just kind of randomly switch like purple and gold, purple and gold. You can do whatever. Like here, yeah. Like you can, here's a website if you want to play with color codes, right? You can go in here and see like for purple, like you can pick the purple that you want. I pick like a KIMEP purple, which is like this hex color. And then the gold that I like is this hex color, and then can make like a column of hex colors that match the, like line them up with the words. So anyways, this is just for fun. It's not required for the task, but I just, you export it as a CSV file, right? And then that is here. This is task for word cloud data file, right? And then if you want to make your word cloud, you just go to this, the link is right here. It's just go there, and then you import. So you just go to words list here, and then you import the CSV file. So, oops. You can drop your CSV file in here, right? And there it is. Like there's the weight and the word and the color hex, right? And then you just apply that. So there's your word cloud. You can size it. The thing I like about word clouds, you can also fit it to shapes. So if you go to shape here, you can fit your word cloud to any one of these shapes. So I did an example last semester with some humanities students, and we had like the two texts were like Hamlet and Macbeth. So we had like a crown, like the word cloud in the shape of a crown. I don't know for a prism, like what's appropriate. Plus, so I don't know. What do you think? It's better if it's like more compact, right? Like some of these weird shapes it doesn't really work that very well. So you can kind of play around with it, but like we can try there's a crown, you can put it in a pond or maybe a castle. What's that? Castle? We'll see. We'll see if some of them, you just have to play with it and see if you like it or not. Like sometimes you can't really tell because of the shape of the words, right? Also, some word clouds like it's
Yeah, I don't think you can really tell that it's a castle. Anyways, I'll just pick like a cloud. You can't even tell it's a cloud. Maybe if the weights are smaller, I don't know. Anyways, so then you just save it as an image. I save that as an image here. Is that here? No, word cloud. Yeah. So, I mean, whatever. I didn't play with it forever, but you can, you can like mess around with it. Also, like if you just want to make word clouds in the future, you can just take this word cloud data file and like manually play around with it, So as long as, whatever you put here for the weight and then the word, and this is like the color hex. The other thing you can add here, which I didn't do, is the URL. So if you put a URL for the word, then the word cloud will actually make it like a word cloud with hyperlinks. So every word you click on will go to like a different hyperlink. So, if you made a word cloud with like people's names, and then you have the name is like linked to their LinkedIn page or their like, profile page or something, like their Instagram. So you can just play with that website. It's pretty easy to make them if you want to play around with those. Okay, so, but the word that's not required for the task. Okay, so then let's say you want to compare two periods, right? So here's like the top 25 keywords, but let's say you want to compare keywords between two different periods. So right now I've got these three files, and I want to, this is like July 20th, July 15th, and April 11th, right? So I wish I had the 34 there, 34, but we'll just do it with these three. So here with this code, you choose the period break, right? So here you put in the date where you want to split the period. Right? So these are your period, these are your doc IDs, right? So 2022, April 11, July 15. So I want to split it here, so I get the July ones and then the April ones separate, right? So just put in any 8-digit number here that's between these two numbers, right? So I just put in like July 00, even though it's not even a date, but it's a number, right? That's like between these, so it'll split. So you can put in the split here, and then it'll, right? And now you have period 1 ID is this, and period 2 IDs are these two. Right? So it's split the IDs. And then now we're going to run the token frequencies on both of those. All right, so here you can see for the first period, which is just that one article, here are the most frequent tokens for that, the earlier period, right? And then we have the most frequent tokens for the second period. So you can see that NSC is all in the July thing, right? There's nothing about the NSC back in April. And also like the anti-corruption stuff, that's like big in July, but then in April, there's nothing about anti-corruption, right? So now you're definitely seeing like some keywords like by differences by time, right? And so the visualization for this, I'm not really sure. I still did it in a bar plot, although I think it looks terrible. So there I create the data set, and then I melt it for R. Okay, so this is like what I'm going to export to R for the second visualization, V2, right? I rank them, so based on the top 25 tokens, and then here's NSC, right? In period 1, there were 0 counts. In period 2, 13 counts, right? So I'm the thing is, if you're comparing, how do you compare like top 25 tokens in two different periods? Because the top 25 in the first period may not be the same as the top 25 in the second period. Right? So what I do is I take the top 25 overall, and then I say what's the frequency of each of these in period 1 and 2, and if it doesn't appear in that period, then it's 0, right? So like NSC is in the top 25, but in period 1 it doesn't appear at all, right? Whereas in period 2 they're 13. So that's how I calculated this, generated this, and then I'll just export that to here, right? So you get the Excel file v2 melted. Go back up to your R file. It's still open. So this is the you just import, right? Import that file, and then the second block of code down here is to make the bar graph. I didn't format these so beautifully yet, but again, yeah, I still need to code these. Yeah, I don't know. I don't really like that visualization, but in any case, like the red ones are period 1, the green are period 2. You can see for this first one, like there is no red, but it's kind of like, I should put the numbers. I think I'll put the numbers on top so you see like 0 and 13. Also, I think in this graph, like 25 is too many. It's like 25 times 2 period is 50 bars. It's like too busy. So I might just like shorten it to like 10. Play with it. Yeah, I'll make these like a little bit more presentable, but here the bare bones thing is there. The last one is prettier, I promise. No, it's not, because I only have the 3 files. If I had all 21, it'd be better. Okay, so last thing is the time series. So the time series of selected keywords. So here, after you've looked at the, like, maybe you want to cut it by 2 different periods, right? Or maybe you want to look at keyword frequencies over the whole thing, right? So here, like, you choose the keywords, right? So here, select the keywords. I just made a list. I chose reform, NSC, and anti-corruption. So this would, however many keywords you put in, that's how many lines are going to be in the graph, right? How many time series are going to be in the graph. So if you put in, you can just put in 1 or 2 or 3. So I made it flexible. So however many you put in, that's how many lines will be in the graph. So reform, NSC, and anti-corruption. The range here goes from 2013 to 2022. You have to put +1 here. So 2013 to 2022, right? So when you construct a time series in a graph for these kind of things, you have to build it completely first with zeros and then fill in the numbers, because otherwise, like, otherwise you won't get like full time series, right? Like the zeros will be missing, and then it's like the shape, each like series won't be like the right length. So, anyways, like, or that's how I do it. So here are the keywords. Here's this is going to be my x-axis, right? I'm going to create a data frame. Here's like my null or empty time series, right? Look at like 2013 through 22 for reform, and 2013 through 2022 for NFC, and again for, right, and they're all zeros. Right? So I construct the full data set. I construct the data structure first, and then I go back in and fill in the frequencies. And that way, if they're like some of the frequencies are 0, those ones I just leave at 0, right? So so there's the data structure, and now we go. Even though this is my corpus index, I only have these 3 doc IDs. So sadly, this time series is only going to show you frequencies for 2022. Damn, I don't know why that pickle should have, this is a bad pickle. You ever had a bad pickle? All right, so I ran this. Yeah. Oh no. So I skipped over this. Yeah, so basically, like when I ran the time series on these 3 articles, I exported to Excel. Okay, so obviously, like anything before 2022 is going to be 0 because I only have the 2022 articles in there, but reform is in there 6, right? NSC is in there 13, anti-corruption is in there 10. Gosh, all right, I'm so mad that didn't work out today. Anyways, so you export that to Excel, sorry, as an Excel, and then you open it up in R and import that, and then you can run the time series. And of course, you know, I only have the 2022 values here because everything else got lost in the pickle. But anyways, like, yeah, it should be like this, you know, whatever. So you can see like one reform, and so you see like reform, and you see NSC, you see anti-corruption, and is it like only in 2022, or have you had it like, you know, other? So you could kind of pick and choose like different keywords and play around with it and create different time series for like 1 or 2 or 3 keywords, right? And visualize it over time. So, yeah. Okay, so that's that. Last thing. This is very important. So this is not a visualization, right? But very important step in the text analysis is selecting articles for reading, right? So recall that a lot of times, you know, you see like the most frequent keywords, or you see the time series or whatever. You're like, I wonder why. Oh, it looks like corruption was like spiked in 2013, right? Like, oh, it looks like the reform keyword like spiked in 2015, right? And then, you know, if it's a bad paper, it'll be like, well, that's interesting, the end, right? But if it's a good paper, then they'll go back and say, try to explain, like, why did reform spike in 2015? Why did anti-corruption spike in 2011? Like, what was happening in 2011 that made anti-corruption spike, right? So to do that, you want to, you know, you're using your visualizations. Now you want to use this data structure, right, to go back in and pick out articles based on features of the graphs, right? So that's what the selected articles for reading is. So you can, let's say, so again, this is not something that you're going to submit, right? But let's say, based on the time series, you saw in 2022 reform spiked, and you want to go back and find all the articles in 2022 that have the keyword reform in them. Right? And you want to pull that subset of articles out so you can read them. And I mean, if this is a massive data set, maybe this query will give you like 1,000 articles, and you're not going to read all 1,000 of them, but you'll pick some of them, right? And so basically here I let you, you know, indicate the year of interest, keyword that you want to query, and then this will pull out all the documents that have in 2022 that have that keyword in it, right? And then it pull them out. Okay, well, anyways, like you've got the IDs here, so you could go like manually look them up, right? But basically, I'll finish this line where basically you could look at them in Python. But anyways, 2022, July 20. So that's, you can either do it manually or just like pull it out. Right, so you can go into this document and you can read, right? This document is about cultivate zero tolerance policy to corruption, right? It's related to corruption and reform. Right? So, and then the second one was 2022, April 11. You can open up that one, find reform, right? And then you can read about it and figure out like why corruption was a big deal in the Kazakhstan's prison system last year in July. So, okay. So what's due for this assignment? So 4.1, the tokens, you'll run that, but you're not going to submit. The only thing that exports is a pickle. And then 4.2 is going to open that up. And then the things that you need to submit are the 3 visualizations. So I want you to submit your code 4.1, task 4.2. You don't have to submit this stuff. Only submit these 3 graphs, right? So the top 25, the top 25 by 2 periods, and the time series, right? So, and how do I know this is yours, right? Because in the title, what you're going to do, you're going to do this for task 3 as well, right? You're just going to say here plus title, right? This is Sanat's top 25 keyword frequencies. Right. So when you, that's all you have to do, right? That's all you have to do to show me that you've run the code. Is put your name in the title and save the file, right? And so so you can upload the 2. I know. Getting smarter. It took me a whole semester. But yeah. So just you just upload your two code files and then these 3 visualizations, right? And so I'll put the specifications up. But anyways, yeah, I'll take a picture the time series when I actually get the pickle things working. So sorry for the not 100% perfect execution today, but yeah, that's the text analysis. It's messy, right? And I think you know, again, like if you wanted to go the latent topics direction, you know, you would still do the process token step, but then you would take that pickle file and open up, you would create a new script file, right? And you would run latent topics. But then a lot of these visualizations are the same, right? But you're just visualizing top 25 latent topics instead of top 25 keywords, right? Or you're doing a time series of like, you know, 3 latent topics instead of the time series of 3 keywords, right? So in terms of the visualizations are quite similar, and that's why I think the R file is still useful whether you're doing keywords or time series, right? But you just have to do another. Yeah.